Thank you, everybody, for coming. Welcome to the U.S. Research Software Engineering Association Education and Training Working Group Seminar Series. Today, we're very happy to have Jonathan Woodring presenting Eating Your Own Dog Food, Testing Your Software Before the Scientists Break It. First, I'd like to remind everyone that we do have a code of conduct that we ask you to follow, which you can reference right here at this link in the chat. And if you're not yet a member of USRSC and would like to become one, you can join on the USRSC webpage at this link here. So now I'm going to turn it over to Sophia, who's our community manager for USRSC, and she's going to give us a quick intro to the organization before we dive into the talk. So Sophia, go ahead.
Thank you, Lauren. Can everyone see my screen? Does it look okay? Or
see it, but the resolution's a little funny, but I think we can all see it. I think that's good enough.
Oh, okay. Okay. All right. So I'll go ahead and get started. Is it still okay? Okay. All right. So hi everyone. Sorry, what'd you just say, Lauren?
I think it's fine.
Okay. All right. So hi everyone. Welcome to our education and training series. I'm Sophia, the community manager at USRC. Our executive directors, Sandra, and our steering committee chair, Ian, couldn't be here today, but they both say hi, and hopefully you will see them next time. So today I'll be giving an overview of USRC and a recap of upcoming events. So USRC started in 2018. We are a community-driven organization, and membership in USRC is free and very simple to opt into. We welcome all who support our organizational mission, and our members are located mostly in the US, but we're also spread out into different countries as well. Our members also come from all types of institutions and organizations, and we are in various types of roles, and it includes those who are RSCs or who identify as RSCs, those who are interested in a career as an RSC, and those who may not be an RSC, but consider themselves to be an RSC ally, a manager, or somebody that supports the role that RSCs play. And our members write and contribute to research software at various institutions. So USRC is focused on 4 main areas. Those are community, advocacy, resources, and diversity, equity, and inclusion. So for community, we're creating and maintaining a professional community to share knowledge, connections, and resources. We advocate by promoting RSC's impact on research and highlighting the critical and valuable role that RSCs serve. In our various resources, we try to provide access to information and material that supports the individual RSCs and also RSC groups. And then for diversity, equity, and inclusion, we actively promote, encourage, and improve diversity within the USRC community and the larger RSC network. So here we have a map of our individual members in the purple and our local regional groups in the yellow. We are currently working on various initiatives to better streamline our resources so that we can support different RSCs gathering throughout the US and elsewhere. We have also been experiencing a great amount of growth since 2019, and we are close to 2,700 members at this time. So on this slide, we have some of our main resources that we use to just foster community and also give RSCs opportunities to get involved. So we have our Slack community, which is also free to join. We have our working groups. We have a community and travel funds program. We have a job board that's tailored to RSCs, and then we also have a monthly newsletter that is kind of built from different members in the Slack community. They share different resources, and we consolidate that. And then we have career guides and an annual conference. So these are some examples of our career guides. We did one with the Academic Data Science Alliance, and we also did one with IEEE. And then our National Labs Working Group put together a guide to help local RSC groups to start up and also to maintain. Does somebody have a question? Okay, and I'm currently creating programming around some of these career guides so that we can better help RSCs get established and network and build community. So these are our working groups and committees. We have a diverse range of working groups. So our most recent ones are our testing working group. We have a user experience working group that started up this year as well, and also a code review working group. Those are some of our newer ones. And then we have like our diversity, equity, inclusion working group, our travel funds program, that's a committee, and just a various array of different groups that you can get involved in. And then we have affinity groups and local, regional, and institutional groups. So in terms of series and upcoming events, we do have our community calls every month. We won't be having one in October because we'll have our conference then, so there'll be more information about that. But we have our Funder Speaker Series. The first season is online on our YouTube. We also have our DEI Speaker Series, which is online on our YouTube as well. And currently our Education and Training Working Group has a speaker series, and they've been putting out content throughout this year. And then we have our conference panels, BOFs, and workshops that we're going to be presenting at the upcoming conference. So in terms of our upcoming conference, we do have our second annual conference on October 15th through 17th. It's in Albuquerque. We hope to see all of you there. Early bird registration ends September 1st, so that's this upcoming Sunday. We also have our full program online. We have our travel support program that's now open, so make sure to apply for that before it closes if you need it. Then we have pre-conference sessions September 16th, 18th, and 20th. And we have tutorials that are online, and those are the week of October 7th. So please remember our code of conduct, as Lauren has already said. And if you're interested in learning more, please make sure to join today. Are there any questions? If not, I'll pass it back to Lauren.
Awesome. Thank you, Sophia. That was great. Yeah, so I think the slide deck that Sophia showed, we could make that available. For the speaker slides, I will have to ask Jonathan first, but usually we also make those available. Okay, so Jonathan, do you want to start your screen share? While I introduce you.
Sure. Can you hear me? Are you still getting the audio click?
I'm still getting it a little bit. It comes in and out. So I'll just give everybody a heads up. We're experiencing a little bit of audio feedback from Jonathan. It comes in and out. So we will do our best to reduce that, but there's not much we have control over.
Yeah, I apologize for that. I don't know where it's coming from. So I picked up the receiver, so hopefully it minimizes it, but apologies. But go ahead. Sorry.
Excellent. So it is our pleasure to introduce our speaker. John earned his PhD in computer science from The Ohio State University, specializing in computer graphics and scientific visualization. He has been a staff scientist at Los Alamos National Laboratory since 2009, where he began his career as a research scientist, developing methods for scientific visualization and high-performance computing. Currently, John develops and supports software tools for scientific simulation setup, primarily for creating code links using the output of one simulation as the input to another. So with that, Jonathan, you can go ahead and get started.
Great, thank you. Is my screen full screen? Are you seeing the slides?
We're seeing the slides, but it's in the not the full screen mode.
Oh, okay. Am I getting lag? Is that why?
That could be. Yeah.
Well, let's go. Well, let me.
This is okay. Yeah.
Yeah. Are you seeing the slide changes?
I'm not. So maybe what I'll do is I'll share the slides from my computer, and then let me know when we
do that.
The slide.
Yeah, please do that since I'm having technical difficulties. My apologies.
Yeah, no worries.
And yeah, we can share the slides later. It still has to go through our LAUR process. You can see I don't have a number yet, but after I get the number, we can share the slide. So.
Awesome. Okay. Is everybody seeing the presentation view?
I see it.
Yes. Awesome. Great. So go ahead, Jonathan.
Thank you. Thank you for having me. So go ahead, next slide. So this is just just a very brief outline of my talk. I'll go into the motivation and background of what I'll be talking about. And my primary focus is just telling everybody to be a user. I'll go into details on what I mean about that, how that relates to software engineering and testing, and talk about, well, what I think we need to be users. I'll talk about my experiences and anecdotes of why I think this be the case, and then we'll finish up with the conclusion. So I'll give a 5-minute break around the 45-minute mark. So I think that will be, if I'm doing my math correctly, 5 till, is it, what would that be, 2 for you guys? Anyway, 5 till the hour. So I'll go for 45 and we'll take a 5-minute break. And I'll try to leave about 20, 30 minutes per question. But I don't know if the format allows for interrupting me to take questions in the middle, but I will take questions if the format allows. But next slide.
I can do that if needed.
Yeah, so just one thing before I get started. I'll be, I guess, playing some shade. So in the sense that since we're talking about good and bad software practices, we need something to contrast, or I feel like we need something to contrast. So please don't be too offended if you feel like I'm singling you out. Though I'll try not to be too mean. But if we can talk about it afterwards. So feel free to reach out to me and talk. And I'll respond to you as best as I can.
Next slide, please. So just a quick recap. Should you listen to me? I don't know. That's a good question, but I've been here at the lab for 16 years. 10 of that was as a researcher, and then 6 of that in the last 6 years have basically been a software engineer, developing software for scientists here at the lab. But I've sort of always considered my job, especially since I was a visualization researcher for a long time, acting as a mediator between computers and people, basically being a translator. And I still feel like that's my job, but yeah. Next slide, please. So, yeah, here's the motivation. So these are sort of questions for yourself. I can answer no to several of these. Do you like writing tests? For me, kind of. Do I like writing documentation? Well, sort of. Do you know which features should be developed? I think I do, but I'm going to say we maybe don't. But in particular, do you know what annoys your users? Maybe you do, maybe you don't. Do you know how your users use your software? And in particular, do you know how to use your software? And that seems like a weird question, right? Like, well, of course I know how to use my software, and I would sort of argue maybe you don't. So next slide, please. Or we don't. I'll try to use the royal we, so I'm not picking on anyone. So if we must do these things, or at least we think we should be making documentation and tests to make quality software. So what is an alternative to writing tests that I can like or I can tolerate? What's an alternative to writing documentation that I can tolerate? How do I know which features to develop? How do I know how my users use my software? And how can this seems like a weird question or a weird sort of statement, how can I learn how to use my own software? Next slide, please. So before I go into the alternatives and sort of the lead-in, the punchline, so I'll just tell you why these are hard for me. Maybe this is true for other people. So tests are boring, right? I mean, it's doesn't feel rewarding to write a test. It just feels like a chore. It's what I enjoy about software engineering, and maybe others here do, is that it's problem solving, right? I feel like I'm helping someone, that I'm solving hard problems, and writing a test, I don't know, it just feels like grunt work. But writing the tests, I find, isn't too hard because we can gatekeep that during the merge request. So assuming you're doing sort of agile and Scrum based, and every pull or merge request has to go through some amount of review, at least there we can sort of gatekeep whether or not a test goes through with your new code. But what about documentation? The software is still going to work whether or not you have documentation or not. And that's lead-in, so a lot of my talk will be not just about testing, but also making documentation, because I think that's the harder thing to do, is making documentation than testing. And why is making documentation boring? Well, it's not coding, right? I mean, I'm in computer science because I like computers, or I like programming, or some combination thereof. And so this is a little bit of an anecdote. So, right, I'm a software engineer as of 6 years ago, but 10 prior years to that, I was a researcher, and so I wrote a lot of papers. And frankly, that was the part of my job I liked the least, was writing papers. And so I'm actually very happy to be a software engineer now, because I don't have to write papers. I do have to give talks, like now, and I actually like giving talks, so that's not too bad. But yeah, writing documentation is not coding, so that's kind of boring. So how do I know which features to develop? How do I know how my users use my software? Well, users don't want to fill out surveys, and I don't want to make one. And there's things like UX, UI studies requirements, but I don't know for you, but here at the lab, I don't have those resources, or they're not immediately available to me. For instance, the software that I work on is like a team of 5 developers, 6 developers, and probably somewhere on the lab, well, I know certainly somewhere on the lab, there are UX, UI experts that I can consult with, but it's not typically something that we worry about, because what we worry about is delivering software that meets the researcher's needs. And that's sort of my lead-in, is how do I know how to use my own software? And we don't know unless we're a user. So next slide, please. So this is my explanation of why we don't know how to actually use our software, or we typically don't. So this is a comparison, or the difference between knowledge and praxis, right? So as a developer, we have a theoretical knowledge of how our software is supposed to be used, whereas a user has practical knowledge of how the software is actually used. So this is the difference between knowledge and praxis, theory versus application. And the example I like to make is a car engineer versus a car mechanic. In particular, I sometimes do car mechanic stuff in my free time, helping a friend with a shop. And it's sort of universally known, or at least within the mechanic circles, that at least the ones that I work with is like, we all hate working on German cars because they're like crammed tight. They're really hard to get to parts. Sometimes you have to like take off the radiator to get to a certain thing. So I sort of joke that I think German car engineers must hate mechanics or something. And so
that's why I say I believe many developers don't know how to use their software. We want to do the fun stuff, the sexy stuff like GPUs or performance tuning or new languages, and we avoid the boring stuff like interacting with users and documentation, making tests. This isn't universal, right? I mean, I actually do sort of like writing documentation. I'll talk about that a little bit later. But at least by my experience of what I see in the software that I develop and the developers, like, it is like pulling teeth to get documentation written. By the way, just a small anecdote, just bringing up here, now that we're talking about theory versus engineering, or theory versus praxis, I forget where it was quoted. It might have been one of the books about Alan Turing, but Turing did sort of imagine, I think this was post-Enigma, when we had physical computers, that he actually did imagine, like, research software engineering would be a profession, because he imagined, or he basically predicted there would be software libraries that we would all share to do our research, and so you would have the best algorithms and math all stored away, and we would share them with each other. And so we're sort of fulfilling what he imagined. So next slide, please. So making development easier. So we've all heard this before, eating your own dog food. So I was also thinking about this, like, does this mean what doesn't kill you makes you stronger? I don't know. Is my software detrimental to people's health? Maybe, maybe not. But so what's an alternative to writing tests that I can like or tolerate? Well, if we imagine being scientists ourselves, or when I talk about this later, I will actually argue that part of our time should actually be doing research. And I think that is true for many of us in this field, that a lot of times we're writing the software for ourselves. But so maybe I'm not talking directly to you, but I think there is value in the rest of this talk if you already feel like you are a user of your own software. And I'll talk about that later, of what I see the benefits to be. Maybe this will give you some additional ideas to improve your engineering. But basically, write tests for your software, what's supposed to do, or what problems it's supposed to solve. At least for me, the reason that I like computers and software and engineering is problem solving, and so let's solve problems with our software. So what's an alternative to writing documentation? That will require some more explanation, but in a nutshell, what I say, be a good scientist. Explain our solutions to ourselves, and the documentation writes itself. I'll go into details on that too. The third one, join a community. We're already a community here, but I would say join a community of your users. So there are, like, many softwares have user groups, and still feels, in some cases, like user groups still feel artificial. In some ways, like there's a barrier between users and developers, and so I'm imagining ways to pull down these barriers. How do you become one of them, or you become more integrated with your users? And how can I learn to use my own software? I'm going to sound like a broken record throughout this talk, but be a user. And next slide, please. And sorry, give me 1 second. I'm going to open the slides on my side too, so I see where I'm at. So is this obvious? I don't think it is. I mean, maybe it is to some of us, that are already consumers of our own software. And many of our software engineering practices take on the role of a user, right? But that's not actually being a user. Again, that's like theoretical versus practical. That's role-playing versus actually being a user. While role-playing does get you far of stepping into the shoes of your users, I don't feel like it goes far enough. So my analogy again, a car engineer versus a car mechanic. Do you think, or just ask yourself, do you think modern cars would be designed the way that they currently are if every car engineer must drive the car they designed and be its mechanic? I personally don't think so. I don't like modern cars. That's just my own personal opinion, so I'm a bit biased here. But I don't know. I don't think, maybe some of you like them. I don't. And my anecdote here at the end is like, I really don't think a lot of the products that come out of the tech sector, say Silicon Valley, I don't think their developers have ever used their products because I don't know how they tolerate them. They do. When I feel like they would just be itching to fix things, but that's just me. Maybe I'm wrong. But next slide, please. So here are my sort of assumptions to being a user, or what we need to do, because it's not free, because when we have talks like these, software engineering talks, a lot of times we'll be like, oh, do this, and this, and I just think to myself, well, when am I going to have the time for that? And so one of the things, obviously, is we have to make time to be a user, or that might mean convincing your boss to be a user. So there's multiple reasons that I think this is a good thing to be a user. As I mentioned before, you become one of them. There isn't a barrier between you and your users. So things become easier. But also, I think importantly, this creates a stake, right? I mean, if we must eat our own dog food, we want to make it the best dog food that we can. We don't want to suffer every single day to use our own software, because good software is more than just correctness. So in the research software engineering, right, we have this unique, or many of us do have this unique position of we're creating software that it isn't necessarily the end goal that it's usable, but it has to be correct, right? We're worried about, say, mathematical correctness, or V&V, UQVV, like validating that our software is correct, or a batch of experiments. And so a lot of times usability is sort of like on the back burner, or in the back of our minds. I think that's why a lot of times, like, testing and documentation is in the background for us, because we're solving hard problems, we're solving big problems, and it just feels like some of these things get in the way of that. And so I feel like by being a user, you're creating a stake. You have motivation to make the software better. Secondly, I do think this requires, well, maybe it requires is a strong word, but these ideas that I'm selling require an agile development, because the process that I see, or how this comes into play in my work, is me as a user and a developer, I'll be using my software. I'll get annoyed with my software, and then that means I want to fix it as soon as possible. And so I may make a merge request or a pull request to fix that as soon as I can. And if you have like a top-down or sort of a waterfall or maybe a requirements-driven design, I could see this being hard to have sort of like this turnaround of like, oh, I'm really irritated with my software, I want to fix it. And so if you have sort of a top-down, now you have to think about, well, how are you going to fit this in to the schedule, and where does it go into the plan, and things of that nature. So I would say it's not impossible to do it with a top-down driven software design, but I definitely do think it's easier using Agile. And number 3 is really related to 1, is a desire to make quality software beyond just correctness. I have seen, I won't name names, but there are development teams out there that are basically indifferent towards user needs. Sort of like the opinion, well, I solved your problem, what are you complaining about? Just use my software. And so I would say there has to be a desire to make things better beyond correctness. And we all have limited hours of the day, and we have to pick and choose our battles. And yeah, I mean, you don't have to follow my advice, but it's just I don't know. It's just I feel like you have to have this desire to sort of embrace the role of the user and try to improve the quality. Even with QA, which I don't think many of us have, being within national labs or university. So QA being quality assurance, if you don't recognize the acronym. I do believe there's additional value by being a user, because even QA is sort of artificial in some sense. They're trying to break the software, and they're not necessarily using the software in the way that users actually do use it. And so I'm not saying QA isn't worthwhile, but being a user has practical benefits. Next slide, please. So you might be a user. So as I alluded to before, many of us already have this hat. In research software engineering, we're already tasked, or at least I am, that's why I am a user, with assisting our users in solving their problems already. Or we're writing the software for ourselves, right? Many of us have sort of morphed where we may have had a background in the physical sciences and engineering, and we took on the role of writing the software to solve our problems, and then it flipped where you became a software engineer rather than a physical scientist or an engineer. So it's probably the case that a lot of us already are users. But so then that sort of raises the question, is like, well, if I am, maybe I should hang up now. I do say, and I don't want to keep you if you do have more important things to do, but is there anything more in the rest of the talk if I'm a user already? And I'll talk about the value of literate programming. I think a lot of you probably already know what literate programming is, but you haven't heard it be called that. I'll talk about nearly free software documentation, how we'll get documentation for free by being a user, better testing coverage, and we're scientists, or a lot of us are scientists or have backgrounds in science or what have you. How do we incorporate the scientific method into our software? Because part of what I'll be talking about is by using the scientific method, by being a user and using the scientific method, we sort of naturally will generate testing and documentation for our software. And so I'll talk about that. Next slide, please. So I'll talk about our software Zelda. I'll talk more details about it later. So currently, that's my moniker, Woodring, right? So convenient and 8 characters. So I'm the senior developer lead of Zelda, and I'm also the #1 user of Zelda. It's not because, or at least I don't think it's because it's bad software. We're still sort of early on in gaining users because it takes a long time to develop some of these scientific software methods. I think a lot of you already know this because we strive for correctness, and there's all these constraints that we have in the sciences and in engineering. So I would say in this coming year, we'll probably get a whole, let me back that up. For certain, we will be getting a whole boatload of users, and my job will get a lot more busier. So my day-to-day consists of shepherding the development of Zelda, but also assisting users to do science with our software. That's basically how I am a user, or I'm the #1 user, because I'll talk later what we do with our software, but in the following is my distillation of the anecdotes and experiences that I've learned over the last 6 years on why I'm trying to convince you should be a user too, not just a developer, but also a user. Next slide, please. So why I think you should be a user. This is the outline for the rest of the talk. So I'll talk about the 3 to-dos as a user and the other benefits. So as I said before, I think by being a user, we get better testing through better coverage testing by following the scientific method. We get documentation nearly for free. I'll talk about what I mean by nearly free. You'll find the bugs before your other users do. You'll be annoyed before your other users are. You'll know which new features to develop and to not develop. Not developing is as important as developing sometimes. And a lot of times we don't like to do this, or at least I don't, but I think we get a lot of free marketing by being a user, which can be important. Sort of I guess a sad state of affairs. No, I won't digress, but a lot of us have to write proposals and sometimes sing for our dinner, and I think being a user helps with getting funding. So next slide, please. So my 3 to-dos as a user and developer. So I'll go into an explanation of 2 and 3 following after this. So be a user. So what do I mean by that? So use our software, solve real-world problems. So our software, most of us, was designed to do research, to do some sort of optimization that engineering cares about or scientists care about, some sort of mathematical optimization. So let's take on the task of becoming a scientist. As I said before, it's not free. You do have to either convince your boss or convince yourself, if you're your own boss, to take the time to do this. And we probably already do, or a lot of us already do. But anecdotally, I would say there are, not all, but many developers that don't know how to use their software. They're just concerned with the back end. And I think that's sort of a disservice to making your software better. So by being a user, we have a stake in improving the quality of our software beyond just correctness. I believe that good software is more than verifying it does AX equals B, right? That's what a lot of our software does, and we go home, pat ourselves on the back if AX equals B or solve for X. we get X, but there's some extra that we could do if we're looking to improve, and I do believe that's why you're here. We're looking to improve, or how can we make things better. So as a user, and this is where it will take explanation number 2 and 3, use literate programming techniques in our research. What is literate programming? I'll go into that. And as a developer, incorporate our research as tests. And that's, I'm kind of jumping the gun, but that's how we get testing for free. So next slide, please. So what is literate programming? Some of you with a CS background might already know this, or maybe it's completely new to a lot of you. So Knuth talked about this in '84. I believe he used it in the development of TeX, which is the back end of LaTeX, right? And this is a little bit of nerding going on here, but Knuth is my favorite computer scientist, just because he actually walked the walk and talked the talk. He actually went out there and did do software too. Like, we've got TeX, and everybody uses TeX. So he's sort of at least for me, my I guess pinnacle of computer scientists. So what is literate programming, though? In a nutshell, Jupyter or R Markdown. There's others, right? Maple Mathematica. It's the idea of a journaling in your programming. So if I take the definition from Wikipedia, a programming paradigm produced in '84 by Knuth, in which a program is given an explanation of how it works in natural language such as English, and it's interspersed with snippets of macros in the source code. Knuth called, at least within TeX, I believe he had the programs were called Tangle and Weave, and that's how he basically did his literate programming, was these ideas of combining natural language with code. So a literate programming language or tool promotes natural language to first class rather than being relegated to comments. So description and explanations are as important as code. I think a lot of us strive to do this, but the literate programming gives you that little extra push, I would say. And I'll talk about it. You may not believe me, but in my own experience, I feel like it does. It give you that little extra push to write the English that we all intend to do, but we sometimes just don't get around to doing it. Next slide, please. So just a quick background of showing you 2 images of literate programming tools out here. So I don't think these are great examples. So on the left is Jupyter. I think a lot of you know what Jupyter notebooks are. And on the right is RStudio. So on the left with Jupyter, unfortunately, it doesn't have any cells that have like the natural language in there. But if you haven't used Jupyter before, basically the idea is that cells can be toggled to be basically markdown, and you just type whatever you want to type. And a lot of you already know, like with Jupyter notebooks, you can embed visualizations and charts directly into alongside the code. On the right hand is RStudio. Unfortunately, there isn't a picture of R Markdown there, but R Markdown, in the next slide I'll show you, basically you interleave code and natural language, and it's much closer, or I would say it's exactly what Knuth was talking about in terms of literate programming. And I actually personally prefer R Markdown way more than Jupyter notebooks. I started with Jupyter notebooks, so just to give you a little bit of background, so I've been writing Python code since 1999, And when I learned about Jupyter Notebooks, I thought they were the greatest thing ever. And then after I found RStudio, after starting to work with statisticians here at the lab, I was like, oh man, this is even better. I love R Markdown. And the cool thing about with RStudio is actually you can do like Python Markdown. And next slide, please. Here you go. Here's my implementation of literate Lua in 2 seds. I do actually use this in my own personal programming. I have literate Lua that I use. I guess I'm enough of a dork that I program at home too. I guess I like computers too much. But if you take this code that I've given you here and you were to actually put it into a text document and pipe it through those 2 set documents and pipe it directly into Lua, this will run. Well, there's a caveat. You would need my libraries to run this, which I haven't given you here. But if you imagine like changing some of the code fences here to something simple like hello world, and you pipe this through the 2 seds, this will run. And so what is literate programming, or what is R Markdown? You can see basically I am toggling back and forth between natural language. And sorry if this is an eye chart for some of you. Once I give the slides later, you'll be able to take a closer look at this. But we're just alternating between natural language and code, and it's seamless. At least in Markdown, it's very easy to mark up a code block. It's like the triple backtick, right? And so that's how you alternate. And I've just highlighted it here to give you an idea of the alternating sort of nature of how you write code. Like I'm explaining to myself, basically. That's how I think about this, is I'm explaining this stuff to myself for later use. Because I'm going to forget. I forget stuff all the time, and I guess that's one of the reasons I document, is that I forget. And so I need to remind myself what I'm going to do. But hopefully if you read this, and I'm not suggesting you read it right now, but if you read it later, I've sort of explaining how you do your initial sort of login on an IRC server. And so yeah, it's not hard to add literate programming into your code. You might be wondering, and I'll talk about this later. I won't talk about it right now. I'll just sort of jump to your question, is like, aren't I just removing like the markup for comments? Aren't I just removing /*/ or // or hash, depending on your language? Yes and no. I'll talk about this later, why I think literate programming is more than just removing comment markups. Next slide, please. So literate programming and research. The notebook style, or what I believe literate programming style, has become a lot more common since Jupyter. I don't think I was really aware of what literate programming was until I had learned about Jupyter Notebooks. Certainly I didn't learn about it in undergrad or grad school. And once I thought about it more and how cool I thought it was, it's just pushed me more and more that I think everybody should be programming this way, or more of us should if we aren't already. And so what does a notebook style or a literate programming style promote? So it promotes testing, verification, and repeat. So that's the scientific method, right? It's like within the same document, you are producing the code that produces the output. You are explaining it to yourself, to others, because you have the ability to basically write natural language along with the output, and you repeat, because a lot of these notebooks are connected to an interactive or scripting language, like R or Python. So I think it's possible, and I have done this in some of my experimentation, it's possible to do this with compiled code. At home, I have literate C, so in the Lewis stuff that I was showing you, and this is the other stuff I didn't show, like I have this whole make file system. Yeah, I'm one of those graybeards that still uses make. That I have literate C, and so you can write compiled code that is a literate style too. So what they do is they promote journaling, descriptions, visualizations, tables, which are embedded in the code on what is being done or what has been done, like a scientific journal during experimentation and research. And just to give you an example, our scientists here at LANL already do this. So I didn't even have to tell them to do this, but a project that Zelda is very closely married to, our simulation software setup tools already promote these ideas where the scientist's research is embedded in the source code and gets continually tested, and it is part of the source. So jumping the gun a little bit, this is what I'm sort of promoting is like, if you're a user, if you're a researcher, in addition to a developer, use your research to do research, take that research, embed it back into your code, and use that for testing, use that for documentation. And I think it will make your life a whole lot better. And we're going to pause here because we're right at the time for a break. Is that okay? We'll take a 5-minute break for everybody, and we'll be back at the top of the hour, and I'll pick up after there. And I can maybe take a few questions very quickly. I know I'm parched, so I'm going to be drinking some tea here, but feel free to get up, stretch your legs, walk away for a bit, and we'll get started back at the top of the hour. And see you soon.
Thank you. Yeah, just for everybody, if you have questions, go ahead and put them in the Q&A feature for the Zoom. I'll leave the slides up. I'm gonna take my own quick 5-minute break. I'll be back in probably less than 5 minutes.
So I'm just reading the questions here from, one's from, sorry if I butcher your name, one from Sognick. Do I consult experienced users or mechanics software code, say E3SM, for instance, to develop test cases when you're new at has to handle software? Yes. So being a software engineer and a scientist, I'm always consulting others because I'm not that smart to know every science, and so I guess that's one of the reasons I said before. I consider myself a translator between computers and scientists because as a former visualization guy, I'm always trying to figure out, or I was trying to figure out how computers are able to explain their science better, and so I feel like I just have a aptitude towards doing this sort of translation, so I'm always consulting with users. Literate programming, it appears to be great for scientists who are iterate or writing documentation with scripts. How does it work with testing suites like PyTwist, writing modules with Python? So this is one thing, and I'll have to ask, I don't know if like Casey Anderson is on, how they handle it, but what I've done in the past is that I know in particular for Jupyter, this is where it makes Markdown easier, is that Jupyter notebooks are sort of a semi-binary format. That becomes really irritating for both Git and testing. And I haven't used it recently, but there's this add-on to Jupyter that allows you to save your documents in basically a Markdown format, where it's exactly like our Markdown, and that integrates a lot better with testing in source code repositories. Because I agree, the notebook binary format is really not great for testing in repositories. I don't remember what the add-on is called, but I think if you look for like, I think it's like, I think someone called it IPyMD. So there's like there's an add-on out there for Markdown. And like I said, with the trick that I've shown you for Lua, you can use that for any language where you can have a literate source code and you just pre-lint it, remove the comments out of the code before you run it through your testing suite. So you add like one step to your testing to remove that stuff, lint it out of there and run it through your test system.
Hey, Jonathan, I'm guessing you answered the question in the Q&A, right?
Yeah, there was a couple of questions that I saw there, and I just answered them real quick.
Great. There's another one. Yeah, go ahead.
I'll answer this real quick too. Question, do you have any tips on adopting literate programming in a general purpose or domain-specific language that doesn't necessarily support it, i.e. PowerShell, Net, and Bicep? So I'm going to talk about what I know specifically. So I'm going to show off my gray beard suspenders here. Is like I'm a Vim user, and Vim within the Markdown syntax markup, you can tell it which code blocks to understand or to basically syntax highlight. And so, for instance, in mine, I have in it Lua and Python and C and C++. And so then when I go from Markdown to code back to Markdown, it automatically switches the syntax highlighting between the fences. There might be that capability for others. The other thing too is like RStudio already has support for understanding other languages with the Markdown format. My sed trick, you can steal, use it wherever you want. All you have to do is change the regular expression from Lua to whatever language you want to strip comments from. And beyond that, to get like syntax highlighting into your favorite editor, I'm not sure other than ask someone for help to do it, because like I said, I'm beyond Vim. I can't really help you too much, but that's how I approach it. Is like Vim Markdown syntax has the ability to switch between different syntax highlighting modes, and my sed trick works for any programming language as long as it's in a text document. And RStudio already has support for Markdown languages. So, oh yeah, someone found IPy Markdown. There you go. I know I had to make like a bug fix. I don't know if it's kept up to date, but that's exactly what I've used in the past, and that allows you to save your notebooks as text documents rather than the binary format, and then it becomes a lot easier to source code track it. So, but shall we continue?
Yes, I think we can continue. Go ahead.
Okay. So next slide, please. So how do we connect literate programming to research software engineering? So consider test-driven software design. Some of us do this, some of us don't. Personally, we don't do it in my software, but there's still a connection. So if we think about test-driven design, you create the tests which describe the specifications, right? Your expected results. And then you flip that, right? So that's what test-driven software design does, is it flips things on its head. You write the tests first, and then you write the software around the tests. So you write the software, validate expected results, and continually repeat with continuous integration and testing or CI. So how does this connect to scientific research and the methods? So if you consider what the scientific method is or what we strive it to be, we formulate a hypothesis, create the experiments, test the hypothesis, and repeat as needed. And what we should do as good scientists, right, is we want to share our results, write a paper. We're supposed to be journaling as we're doing our experiments, right? We have a scientific journal, we document it, and that's a literate program, right? A literate program or a literate programming tool is explaining to ourselves or our audience, what does this code do? What does my output do? How do I connect the two of them together and integrate the two? And so if we consider taking literate programming as a model for writing code for testing and documentation, then we kind of get a lot of stuff for free, I believe. So next slide, please. So this leads into my number 3, as I was talking about before, is like treating testing as experiments or vice versa, or incorporating the ideals of the scientific method into our software design and engineering. So develop research software, create an experiment with that software, or what we would call a test, but use a journaling system. And what I mean by journaling system, right, is literate programming. Use the experiment to test your software, and use the journal to document your software. I'll talk about that more, about what I mean about use the journal to document. Just repeat, and that's the scientific method, right? Is software testing in some sense is the scientific method, but we just need to add a little bit more to help us do this, to sort of incentivize us to strive to be, in some sense, better scientists, be a scientist, be a research engineer. But there's a little bit of a chicken and egg here. Which came first, the documentation for the software, the test that documents it? So if we consider test-driven design, the test comes first, and then the software around it. But in reality, we already have our software. This kind of only works best if we're starting from scratch and do test-driven design. But I get that it's a little bit of a chicken and egg if you don't already have this. But in some sense, if we follow the scientific method, the hypothesis comes before the experiment. And so the test is written before you actually test. Next slide, please. So what do I mean by nearly free? So I'll use a little bit of computer science here. So as a side effect, so in functional programming, we have this notion of side effects, right? So things that happen on the side, because a functional program is supposed to be a closed universe. And that's the funny thing, right? Is like if you look at Haskell, I/O is a side effect because you're interacting with the real world. I find that just hilarious. But so that's the thing, is like I'm in some sense telling you an idea or a discipline. If we follow our principles of the scientific method, then we ought to document our experiments. It's got to be done eventually, folks. So I'm not selling you something that's like, oh, throw your code into ChatGPT documentation for free. Maybe that works. I don't know. I've never tried. But I don't think it's going to work. But maybe it would. So my quote unquote trick is, let's incorporate what our colleagues are doing, scientific method, or we hope that they're being good scientists and following the scientific method. Leave documentation. So looping back to it, so be a user, be a part-time researcher, collaborate with them, tutor them. Don't isolate yourself behind the code. That's kind of what I'm selling in a nutshell, is we have to interface with our users, and if we do that, we get a lot of benefits from doing that. incorporate our or their experiments into the software as CI as tests. So utilize what we do as users and pull that back in. If you're not going to be a user, what I would start doing is going to your users and see if you can gently ask them, hey, can you share some code with me that I can pull back into my software and use as a test and also the documents. Maybe they're happy to do that, maybe not. I don't know what your relationship is with the users, but it's a starting point. And 3, automatically extract the documentation using AutoDoc, like Doxygen, Sphinx. You don't need Jupyter Markdown. My two-said trick can make any programming language into a literate one. You would just had to add to your build system to recognize that code that you're adding is documentation to be extracted as well. So when I say documentation, I'm being a little bit more specific here. Is like, I'm imagining you have like an HTML page or a PDF that is like a user guide or explanations or tutorials. And that's what I'm sort of talking about here, is like the chore of writing that and how to make that as painless as possible to make that document. Maybe you don't have that, and maybe your code is in some sense kind of following what I'm talking about here, is like, oh, how do I know how to use your code? Oh, go look at the examples. Great, you're like almost all the way there. The only difference I would say is actually solve real problems, or get problems that are actually solved and pull it into your code and test. Next slide, please. So real world example, so I'll talk about the software that I work on very, very briefly. Some of you may pick up the reference here. Bonus points if you do on what Zelda is. But so our tool creates what we call code links. So imagine taking one simulation, say an engineering, say Abacus, and we want to run it in, say, a multi-physics simulation. So Zelda, the software that I work on, what it does is a part of simulation setup software. So we can take the output of one simulation and create the input for another. So it does things like mesh transfer, field transfer, things of that nature. And it also interoperates with the rest of our simulation software ecosystem. And so it all integrates together. Next slide, please. So Zelda experiments or tests live in the continuous integration. So that test that I just showed you, that picture on the right-hand side, that rocket test actually lives in our CI, along with other examples. And we also do external tests too. So we do the entire user workflow in the sense of the parts that we touch, or as far as we can go. So the output that we ingest, say simulation output, is part of our CI, and we do the transformation, and then we actually do run the next simulation in the step, only for a couple of time steps because that's expensive. And we do regression tests on the output of that to make sure what we generate is still working with our downstream consumer. And so we are incorporating real-world tests into our testing and also using that as a way to document back to our users. This is how you use Zelda. This is a real-world example of how you use us. It's more than unit testing. Next slide, please. So Zelda builds, extracts our documentation via Doxygen. So I'll talk about this a little bit in the next slides. I think it's the next slide. But what if you have a GUI? And I'll talk about that. But for us with Zelda and the rest of our simulation setup software is that we're user interface in some sense is code. Our users basically script simulation setup. So we already have the idea of doc strings, in that when we generate documentation, we're really pulling out doc strings and putting those into a PDF. But a tutorial, the lack of a tutorial doesn't impede your software from working, right? So that's sort of like why it doesn't get done. Our software still works even if I don't write a tutorial. So how can we make the time to create them? That's sort of what I'm talking about here, is if we have tests that are real world tests and show how to use our software in the real world, and we instrument it with Autodoc, and we use literate programming that recognizes how to basically strip the code from literate programs and pull that into, say, some Autodoc, and puts it on your HTML page or puts it on your PDF, and you got your documentation for free in some sense. I mean, it's not completely free. Still got to write the test and document it, but I don't know how to say it, folks. It requires discipline, but this is how I sort of get myself to do it. I'm just sharing with you of how do I get over these speed bumps. Or the other trick is that, like I said, steal stuff from your users. Hey, do you have some examples that you're willing to share on old research that you've done that you don't mind being published now because it's already been published in your paper? Because that is something that tiny little bit of thing that you have to worry about treading, because I know a lot of researchers don't want to get scooped, so you can't take their latest stuff and put it in your source code and documentation. But maybe you can get their old stuff. And so, like I said, Zelda is instrumented to recognize these tests as part of the documentation, and then use that as tutorials for our user. And so the users know how to use your software, so let's leverage that knowledge. They know all the quirks of your software. Next slide, please. So what's this all about then? And you can see my little tiny note up there. Am I lazy? Let's just say I'm efficient. Using software development and testing process to make the documentation and testing so it doesn't feel like a chore, tricking myself and others into doing it is part of their duties. And what I talked about before, don't add extra labor on top, make it part of our current duties or an alternative. So when I say be a user, don't add it to your existing role, split your time. Like I said before, you have to convince your boss or somebody, like, I need an extra half time to do this thing, or half of my time is spent being a user, or interacting with users, being embedded with users. That's actually something very common here at LANL, is that a lot of our, well, it's changed recently where they're sort of split, but historically in the past, like, software developers were directly embedded with the scientists. There's a little bit of separation now, but I'm saying let's reverse some of that. If you can't get the time, require that your users, or ask very nicely, please contribute your experiments back to the source. We do this with our other piece of software at LANL, our other simulation setup software. All the experiments are part of the source. And just my note there at the bottom, typically when we get advice, we say, oh, do this and this and this. And then I'm always thinking, okay, when do I have the extra time for that? Let's be realistic, folks. What I'm selling here is like, yeah, you gotta split off some of your time to do this. Next slide, please. So the added benefits, so the life cycle of an experiment. So like I was talking about before with our LANL scientific software, consider the scientific method, hypothesis, test and repeat, and share, right? I mean, we write a paper, do a presentation at the end. So in my world, Department of Energy, Office, and I think NSF is the case too, proposals must have a data management plan, which basically asks you, how do you intend to archive and share your research results with the public and research community? So we're killing another bird with one stone if we do this, right? So we can solve that. So if we're doing our research, and our research is part of our software suite, and it's getting tested, it's kind of automatically shared and archived and repeatable. We just write in the proposals, oh yeah, all the research that is being done with the software will also be in the software itself, and anybody can use it, download it, and repeat it, and will be repeated nightly, or however your CI works. And yeah, another thing for free, check the box. Next slide, please. So caveat though, CI tooling for GUIs. So what if your software is GUI driven? Yeah, it becomes hard to implement what I'm selling here. So kind of in some sense, it needs a way to record and replay the GUI interaction along with the journaling tool. And I'm not suggesting like make videos of using it and then document that and then put it in your source code. That's kind of silly. And in some sense, you're not getting something for free there. I've been thinking about this a little bit and what's the best way to do this. The only thing I can think of is that, geez, I hope your GUI software is sort of like written in a model view controller paradigm. Then you could add a scripting language on top of it, and you could script all your tests. And power users, they do like scripting, and I'm not a UI UX expert, but I believe, right, is like novices tend to use the UI, and then the more scripting you add, and the more over time power users use your tool, they'll use those tools rather than the GUI tool. So I don't have a good answer for you. If your tool is a GUI and sort of incorporating some of these ideas. But if your software is command line driven, well, hooray, all you need is a shell script, and then you can repeat a lot of these ideas. Just imagine you're running quote unquote experiments from the shell, storing that in a shell script, and then add my toSed trick on top to make literate bash or whatever your favorite scripting shell is, PowerShell. And as I said, very little must be done to add basic literacy. RStudio has support, what have you. Next slide, please. Other benefits, finding bugs before the other users. So this is anecdotal, but I find bugs in our code running it through real world test cases than our testing, right? I mean, we hope that we get good coverage in our unit testing and the testing that we produce in implementing features, but there are so many more bugs I find in using the software in real world scenarios. I mean, that's the joke, right? It's like, how do you debug your software? Well, give it to a user. They'll break it for you pretty quickly. Let's leverage that. Let's incorporate that. Let's not make that a joke. It is true. Anecdotally, it's true. Your users will break your software. So why not be the user and break it before they do? In particular, you'll hit all the cases that didn't occur to you during the design. One example that I'll give real quick is that we have this output file format, and since we're working with simulations, simulations of physical things, things have materials like aluminum and steel, and they have names. And so it didn't occur to us that a user might have put a slash in a material name, and obviously that interferes, at least on Unix systems. A forward slash is a path separator, right? And that doesn't play very well if your file name has a slash in it already. So, oh, where's the directory? I only found that through actually using it. So, next slide, please. So, building good habits. As I said before, we have to dedicate ourselves to doing this. So this has to be a conscious decision to do these sorts of practices. We must, quote unquote, be a good scientist and journal our research. So, as I mentioned before, I approach it as being a tutor to myself. I'll forget, and if I don't explain these things to myself, I'm going to forget. But it only sort of happens by being the user of your software because you're trying to solve hard problems. Because that's what I find interesting about, I guess a lot of us, all of us do, about either computer science or programming or the physical sciences, is solving interesting problems. And so we have to do this in the context of solving interesting problems. So I have to write a test that solves a real world problem that is interesting. And in that process, promise to myself that I will be a good scientist and document my research and my results and make sure it's embedded in the journal. Yeah, I don't know how to do it other than like, let's suck it up and be good scientists. So the other thing too is like utilize rubber duck debugging. If you guys don't know what this is or you can call it teddy bear debugging, you have an inanimate object that if you have a hard problem, you explain your problem to the inanimate object, or you can have someone else be the inanimate object, the rubber duck. And through the process of explaining the problem, them, or the rubber duck, you usually come upon the solution. You figure out the solution. Well, let's also make sure we document that. Write that down as you're doing that. And that's really how I approach things, is that I don't know why, but for me, it just works well if I get into this mode of being a tutor. If I think about being a tutor, and especially tutoring myself, it just sort of comes naturally, I guess. I think part of it is wanting to also be a good educator. So this trick may not work for everybody. It works for me because I like explaining things. I like people understanding, and so if I approach it that way, then I get motivated to do it because I want someone else to understand. Next slide, please. Development by being annoyed with our software. So as I mentioned previously, development can be indifferent towards user needs. So I call this developer blinders. If you're sitting in the background and you're just managing correctness and performance and other things that you can quantify, then who cares about the user? I mean, let them figure it out themselves. So if you're a user, then you get annoyed, or at least I do. And then I'm like, I want to fix this. And so then that immediately turns into lots of merge requests from me fixing this. And in my experience, you don't get these merge requests happening because your users may not tell you, depending on your relationship with your users. I sort of make this sort of like politics. So for a politician to get a vote, you have to talk about how to solve your problem or the voter's problem to get their vote. So you have to make the user's problem your problem to sort of improve the quality of your software is really all I'm saying. Fixing all the things that are, oh, that's not a bug, that's a feature. Next slide, please. And not developing features, shielding your users from dumb decisions. So as developers, we know what can and can't be done. So we know, oh, it's got to be this way because it was designed this way, and oh, sorry, we painted ourselves into a corner. So sorry, it's going to take us some time to add this feature. And so by being a user, we kind of makes our life as a developer easier because we know how to prioritize tasks, because sometimes that can be hard. And also estimating how much time it will take to implement a new feature, because sometimes the user will come along and say, can you do X? And that kind of comes out of the blue sometimes, and you got to put your mind in the context of like, oh, can I do that? And a lot of times, my team leader gets upset at me because I'll be working with the user and they'll say, oh, can you do this? I'm like, oh, sure, that's easy. And I think, well, I know it does upset him because he doesn't have a context of the code to know whether or not that's easy or not. And so I'm too eager to solve the users' problems, because while being a user and a developer, I know how easy or hard something is, and I'm just like, oh yeah, that's easy, we can do that. Or I'll be like, oh, let me think about it, that's gonna be kind of hard. But related to that, by being a user and a developer, we can block changes, because sometimes, well, as I said before, developers really, if you're not a user, you really only have a theoretical understanding of your own software. What looks good on paper may be terrible in practice. I don't know, there's, let me point at so many pieces of software from the tech industry. I think they thought it was a good idea, but it's terrible in practice. And the other thing is, like, ensuring forward compatibility is subtle. And for instance, like, right, we try to follow the major.minor.patch, or a lot of us do sort of version control thing, and like a minor version typically is supposed to be forward compatible, and you only do backwards compatible breaks on major changes. I find that unless you're a user, you still end up breaking things that are not backwards compatible, even in what you consider to be a minor version change. I've had it happen to me in our software. I'm sure I've done it to others too. And so you help sort of minimize this by being a user. Next slide, please. Cheerleading and marketing. Yeah, a lot of us don't like doing this. I know I don't. I'd rather just be coding most of the time. It's why I'm a software developer, not the team lead. So by being a user, we help grease the wheels, move things along. Funding, it's just a fact of life. I think being in this line of work of research software engineering, being in the university and national lab, or maybe industry, but you live off of, say, I don't know, CRADA or what have you with the DoD or DOE. So we have competition, and so marketing for free as a quote-unquote side effect. So if we find the bugs before our users and get annoyed before our users, I mean, we've got better software. They aren't getting annoyed. So in some sense, we're getting ahead of the curve of fixing the things before they go and complain about it to our division manager. And then it trickles down to us, and then it affects our line of work. And the division manager's coming on our doors like, oh, why did you break this? And you have to answer those questions. So kind of getting ahead of the curve. Requests gently require content from your users. When you're doing that, you're building a rapport, right, with your users. And so being integrated with your users, so you're one of them and you're not an outsider, because this is the other thing that I'm whoops, sorry, my screen went asleep there for a second. Is that breaking down the barriers between a developer and a user. I'm not saying you want to go out and have a beer with your users. Maybe you do, maybe you don't, but at least not having an antagonistic relationship. I'm not saying all of you do, but I have, or any of you have this relationship but like I was alluding to before, I have seen development teams where they're like, all I care about is like, if this checks the box, solves the problem, and my division manager or group leader is happy, who cares what the users think? I did my duty, you figure it out, and I don't know. To me, that doesn't sit right. Maybe that's okay with you, but again, I'm accused very often of doing too much. So don't necessarily follow in my shoes of do protect yourselves. So that's the thing, is like, don't get walked all over. But anyway, just thinking of ways to be better compatriots with your users. Next slide, please. So wrapping up, and I only have like 4 minutes left, so this is a good spot. This is a work in progress, so any feedback or comments are welcome. Software development's always a moving target. Literate programming, isn't that just removing the comment markup? Yes and no. I mean, it's hard to explain if you've never used Jupyter before. I think it's the bee's knees. I love it. I don't know how to say anything more than that. But in my experience, it eases the barrier to toggling back and forth between code and natural language, sort of getting your mindset into sort of, I don't know if this is true anymore, but, and I'm probably pushing pseudoscience, like flip-flopping between the left and right brain. I don't think that's necessarily true. But anyway, if you imagine, if you go by my pseudoscience, sort of like easing that barrier. And Knuth agrees with me. So he sort of does contrast that. He says HelpDoc or AutoDoc systems are not literate programming, and I do agree with that. And all I'm saying is that let's use literate programming in building tests, and we use AutoDoc to help us to generate our user PDF and manual. But yeah, literate programming is not AutoDoc, but we can use AutoDoc to help. Next slide, please. Generating documentation beyond tutorials, GUIs. We have HelpDoc, AutoDoc. So higher level documentation like introductions still need to be written. I don't have a way around that. Maybe some of you will tell me ChatGPT, but I haven't done that. And like I said before, it's not clear to me how you do this if your software is primarily GUI driven. I guess I hope your software is model view controller, and then you could add a scripting interface to it, and then you have a way to test your software outside of the GUI. But I know there are frameworks out there to do GUI testing. I just don't know a way to combine it with literate programming. Over prioritizing your own work. Yeah, if you become a user, of course you're going to bump everything that you do to the top of the list. Hopefully that's the most important, but and you don't have anything to worry about, but unlikely. Next slide. Novice tutorials, where did those come from? Yeah, that's a problem if you're adding these ideas to an existing software and you want to backport. So if your software is just starting, right, the novice tutorials are sort of like for free. They come, I mean, you're writing easy problems from the very start, and so like you, in some sense, writing user tutorials if you follow this idea. So I don't have a really good answer if it's a mature software. Maybe become a user. Well, I guess the thing is, like, maybe task one of your developers that's like deep in the code and go tell him to be a user, and they don't know how to use the code, and so they're a novice and they end up writing a novice tutorial for you. Are these ideas hard to implement? Technically, no. Socially, hard. Yeah, you got to have buy-in. the same. It's the thing with all this software engineering stuff. Wouldn't it be nice, science and computer science and programming be nice if we didn't have all these users? Yeah. Next slide. Large experiments and data sets can't be easily incorporated into the CI. Yeah, that's true. Partially it's a Git problem. If you use Git as your source tracker. For us, large data sets are stored in a place that's accessible to the CI, and long-running tests are only run infrequently. Say, for example, weekly. Obviously, we don't run something that's going to take an hour every time someone does a merge request. In a new project, who are the users that Bootstrap tests? Well, we are aware of the users, but a little bit less tongue-in-cheek. Oh, sorry. Skipping to the end. But yeah, I didn't talk much about testing. This was a lot about documentation. Yes and no. I think documentation is harder than testing. So by becoming users, we make the tests and document those, and then we pull the documentation back into our documentation, and then the circle of life continues. But the other thing too that I didn't talk a lot about is that by incorporating real-world tests into your software, we're also supporting the scientific method in their science, because if they're doing science and we're testing their science, then it's repeatable. We're repeating their science, and pats on the back all around. We're all doing good science. And that's it. Next slide, please. And I'll leave roughly 20 minutes. Do I take my own advice? Mostly. You can read this later. There are some things I don't do just because I came in afterwards, but I would say within the year we're going to be doing everything that I've talked about. There's just a couple of things left to implement that have not been implemented. And last slide, please. My 2 cents, be a good user of your software, be a good scientist, journal your research, pull your research back into the software testing or other scientists or engineers back in. Use that as documentation, repeat. Give ourselves a pat on the back, and that's it. Thanks. Questions, comments? And Lauren, can you just skip to the next slide? It just has acknowledgement. Oh, sorry, one more. Just acknowledgements and leave that up. But thank you for listening. I went a little over on time, but we have about 15 minutes left for questions. I'll be happy to take them. Lauren, are you going to moderate, or should I just read from the chat?
I can moderate. So
okay.
Let's see. So I've been asking folks to put their questions in the Q&A panel. So just for everyone, start putting your questions in. We had not a question, but a comment earlier. Using type hints in Python is free documentation. The more you use it, the better your life gets. So that's.
I'm sorry, what was that? I didn't catch it. What in Python?
Type hints.
Oh yeah, type hints. Yeah, that's a great one too. We do use type hints too. So we've got type hints in our API, and yeah, I agree. They're great, and we don't have MyPy testing turned on for our stuff, but it's in there when we do turn it on, because I do want to turn it on. And yeah, I agree. Type hints are great for Python.
Great. And then we have the question, can you share the repository for Zelda or something to understand it's working? I'm guessing these references might.
Unfortunately,
help.
No. So what I could do is, so these slides should be available to you sometime within the week. Now that you've said that, let me make a note to myself to document as much as I can. So if you do scroll forward a couple of slides, I do have more technical details about Zelda itself in the appendix. And I can just add more to it of what I've implemented and how the inner workings work. I didn't go into those details, but I can certainly add those to the appendix because unfortunately, I can't share our software. I wish I could, but I can at least describe how it works. Sorry about that, but I will make a note to myself to add that to the appendix so you have something to go by and some guidance on that.
Great, thank you. What is your opinion on using Git for journaling? I'm thinking about features of tagging and release management.
Git for journaling. I'm not sure if I get the question 100%, but in general, I think Git is a great tool beyond just source code management because just taking notes and things of that nature. So I think literate programming, the thing that you're flipping to doesn't have to necessarily be code per se, but it can be technical documents of some sort. Like if we're talking about tagging, like one of the things that I do or try to do is keep a technical record of why we did releases, for what reasons and why. And that might be kept in a table, and so I could see like having a literate document of that alongside the technical details. Did I answer the question, or am I off base there on what was being asked? I hope I got what you intended, but I don't see why you can't sort of use literate programming and more things, and I definitely be using Git as a journal for other things. I mean, just in the way that I use Git personally is I'm a very frequent committer. Like I'll do something and I'll immediately commit it and hit OK. And so actually I tried to build this is sort of a little bit of a tangent. I had a research idea that I never got the funding through, maybe somebody else can get the funding for this. But I had this idea, and I've implemented this partially, of where the IDE was built into the build system and built into the compiler. So it actually would, in some programming languages do this, like Python, where you can say put the tests at the very end of the code. And I had a very similar idea, but doing it in a literate programming way, because if you think about taking this to the next level of doing like a complete circle of life, why don't we have, like, if you consider test-driven design, you make your tests, you write your hypothesis around the test, and at the top of that same piece of code and document, you write the code that implements the output of that. You have the output of that embedded in the code. That's a little bit tricky with pure Markdown. Our Markdown, they have a way to do that in that the markup will link to like a table or something like that. But if you think like a full circle of life, like you got the tests in there, you got the implementation in there, you got the explanation why you tested it, then you're doing like a full scientific method within one document. And I had this research idea of like, how do I have like an IDE that integrates with the build system and the CI, and it all understands literate programming and is all able to, in some sense, give the different users a different view of that document, because sometimes maybe you only care about the testing, like maybe you do have QA and they contribute to this literate document that augments the testing, and then you as a developer, maybe you want to, in some sense, collapse, because like if you think about, if you're a Vim user, you have this idea where you can collapse things between curly brackets, and you could do the similar sort of thing. Or even code, like collapse all the code, let me read this stuff as an English document, or reverse it the other way around. anyway, yeah, I had this idea that would be this full circle of life of literate programming, because yeah, I just think it's, I don't know, I love literate programming. But yeah, I got on a bit of a tangent. So.
Thank you. Yeah, we have another one. How are you integrating code that exists in a notebook format into CI pipelines?
Yeah, so and this is something I'd have to ask Casey, and maybe I can put that in the slides technically. So I don't know how they do that exactly with the IPython notebook format, because that is a little bit tricky, because that is a semi-binary format. When I do it, and especially with R Markdown, is that there's a linting process. But so say I have a literate one that is compiled. Basically, the toSed thing that I showed you, that's part of the build pipeline that would strip out all the stuff for the compiler, so it gets fed through. So in some sense, it's stripping everything away, and it's a lot easier than stripping comments, right? So in some sense, if you follow my style, where you have a literate document that's Markdown, it doesn't matter what you write in the Markdown. You don't, in some sense, you don't have to write a interpreter or a compiler that can get around your messy English language stuff. Because as long as you follow the Markdown markup, which is the triple backtick, that's super easy to parse. And like I did, you can do that with two seds piped back to back. And so our build system basically strips that out before it gets fed in. So you got to tool your build system a little bit to recognize that document format and feed it through. For instance, at home, my make files understand a .lua.md format, and then when it sees that, it knows how to transform that into a Lua file by piping it through my sed pipeline and strips out the documents, and then it runs just as code. So that's the thing, is like strip it out. So feeding it back to the results, you would have to instrument that in a way. And I'd have to think about that more, because we haven't done that necessarily, because yeah, that would be cool. Now that you've talked about that, that would be cool if there would be a way to then, at the end, after the testing run, link the output of the testing back to, say, like JUnit, so it's showing up in your dashboards. And then when you see the result of a failed test, then you can also bring up the English document that explains what the test is supposed to do. But we don't have that. That would be possible and be neat. Yeah. Another question? Is that
Do we have any other questions? Okay,
If
well,
not,
we're finished.
Thank you all for your time. I appreciate your time. It was fun giving you guys a talk. Hope you learned something, or at least learned maybe what not to do if you thought I was full of bunk and then you said, he's full of crap. Don't do that stuff. So, but I hope it was at least entertaining.
Yes. Thank you so much, Jonathan.
Yeah.
Before
My
we leave,
pleasure.
I do have a quick poll. We'll skip the poll today, but I'll remind everyone, we will make this recording available and the slides once we get those ready to go. And again, if you're not a member of USRC and you'd like to become one, feel free to go ahead and join on the webpage. So thank you so much for coming. Have a great rest of your week.
Yeah, thank you. Thank you, everyone. Bye.
Thank you.